Chris, welcome to the show.
Sean, thanks for having me.
All right, well, let's start off with some basics. Who are you and what do you do?
Sure. My name is Chris Van Pelt. I'm a co-founder and the Chief Information Security Officer at Weights and Biases. This is actually my second startup. So Lucas, our CEO at Weights and Biases, and I started another company, almost 15 years ago, also in the machine learning space called Crowdflower that rebranded to Figure Eight that helped people label data that was often used to train machine learning models.
Yeah, awesome. And I know you've been working in the ML space for a long time. You know, the company that you started, 15 years ago. Before that, I believe you also worked with PowerSet and now Weights and Biases. What have been some of the kind of biggest changes that have happened during that time? And that's a long time to be working in a singular space, but let alone like I think machine learning AI is something that is really exploding right now. So I'm sure there's been a significant amount of change.
Yeah, well, one of the changes is we started calling it AI. That's a buzzier, more exciting word. But in my career, it's always been machine learning, which is really using statistics to model relationships between features. A big thing that changed is that deep learning really started to take off. Certainly more traditional ML models are still very useful and being used in lots of contexts. But about 5 years ago, around the time we started Weights and Biases, we were seeing that deep learning was becoming really big, especially in like autonomous vehicles and computer vision. And then since then, we've seen this explosion in natural language processing and these generative vision models. Which is, it's kind of wild, kind of full circle, because the PowerSet job, my first job in Silicon Valley, was all about natural language processing and how to return better search results using machine learning methods. And the methods we were using that are very different than this new wave of machine learning.
Yeah, it's interesting there that you mentioned the change that we're now referring to it as AI. During my master's degree, which I was actually in the machine learning space as well. My master's thesis supervisor, he used to always refer to it as pattern recognition, and he would say that the name would change every decade or so whenever sort of the funding started to dry up for one particular name, and then they would go and change it to kind of reposition it and secure new fundings in academics.
Yeah, that's totally true. But I mean, I will say, like playing with ChatGPT, it doesn't feel like simple pattern recognition, right? It feels like something more magical,
Yeah.
for sure. So I don't know if we should call it AI or just really good automation, but it's definitely a big deal.
Absolutely. So, you're the co-founder of Weights and Biases, which was, now over 6 years ago, way before I think the world has become completely obsessed with this field of AI in the last year. And my understanding of Weights and Biases is that it's an ML platform geared towards helping developers and researchers build better models faster. So, first of all, is that a fair description of the product?
Yeah, I think it's a great description. It's not very, yeah, it's hard to describe a product as kind of broad and complex as ours, but that's a good high level overview.
hmm But going back to when the company was originally founded, what was the problem you were originally sort of focused on trying to solve?
Yeah, so back in 2017, Lucas, my co-founder, actually got an internship at OpenAI. He did this because we saw that deep learning was really taking off, and our personal like ML chops were getting a little rusty, having been running a separate company for the last 10 years. And Lucas got his master's degree in machine learning from Stanford and was able to work on a problem at OpenAI, a specific robotics grasping problem, to figure out, how to move a specific robotic hand-like thing to pick up an arbitrary object. And as he was working on this problem, he was just having trouble keeping track of all of his experiments. Like the actual models that he was creating, he was just putting them in folders on his desktop, and then maybe writing down notes in an arbitrary document somewhere. So we thought, well, there should be like better ways to do this. And there's a bunch of rich information we can collect about the experiments kind of automatically. So we set forth to create a nice little Python SDK and web application to just keep track of his own experiments.
Mm-hmm. And then from there, like, how is the sort of vision for the company and the breadth of things that you've done, that you do today, and the sort of different, workflows that you might serve? How's that evolved over time? You mentioned that, it's a pretty wide product. There's a lot of things that you can do with it.
Yeah, well, we really focused on this, core kind of experiment tracking problem first, and then when we built a product, it wasn't clear. We thought it was cool and thought it was useful, and it wasn't clear if we were going to be able to convince other people that it was useful. So in the early days, it was just talking to as many people that would listen to us, and then working as closely with them if they did engage to figure out how we could kind of improve the product to address any pain points that we hadn't anticipated. Naturally, as we did this, we started to hear pain points from other parts of the machine learning workflow or pipeline. So one of the first features we built just outside of experiment tracking was making it easier for teams to automate hyperparameter sweeps. So when you're building these models, you kind of have some arbitrary number of settings, and you don't know which settings are going to be the best. The state of the art is to just try as many of them as you can, hopefully intelligently, so that you can find the correct settings to make your model perform the best. So we launched sweeps, which helps users do that. We knew that when you're doing machine learning, the data coming in and the models coming out, it's really important to keep track of them and understand what code produced them, what hyperparameters were used. So we created artifacts, which allow you to track data lineage across a pipeline. And originally, we weren't making a super visual product, but we quickly saw users say, hey, we want to see all these charts and compare different metrics and different evaluations against each other. So we've invested a lot in our kind of data analysis functionality. So users can create rich dashboards, compare evaluation results, and share essentially reports with other team members to collaborate. The newest functionality we've been working on is production monitoring. So kind of after you've done all this experimentation and chosen a model, now how do we make sure that it's doing a good job out in the wild?
Yeah, so you're basically serving the full life cycle of the model, essentially from to actually operationalize it.
Yep. I mean, our mission is to build the best developer tools we can for machine learning engineers. So we're looking for any pain points developers have in this journey and how we can make those as painless as possible.
And outside of, like a product like yours, how do people, like, historically or even today, like, manage experiments and measure results if they aren't using something like weights and biases? Is it, going back to what you mentioned with your co-founder, the sort of bespoke solution of using a bunch of folders and cobbling something together that works for that particular experiment, but maybe is not a very scalable solution?
Yeah, that's still something we see today. Especially if you're just working on a project yourself, you can kind of come up with whatever way you want to keep track of those experiments. So we often see very ad hoc approaches where things are just going into a folder on a desktop somewhere or into a cloud storage bucket somewhere. And then there's like a Word document or a Google spreadsheet that kind of writes down notes about different things in that folder. That starts to fall apart really quick when you're working with multiple people. So it's similar to like regular software development. People didn't realize how important source control was until we had these teams of tens or hundreds of developers needing to make changes to the same underlying system. So we thought when we started Weights and Biases, this is like the early days of software development. There aren't great tools to help developers collaborate. So that's what we set out to create.
Mm-hmm. Yeah. So it sounds like because there's essentially growing investment and also the scale of these models now is much bigger than they were, 10 years, 20 years ago. And also we've moved beyond just this being something that was happening in like an academic lab to now being, productionized or productized essentially through whether you're in the LLM space and building foundation models, or you're building essentially a company that leverages a lot of these different things. So you need a completely different tool chain because there's so many people involved with those products. Just like you're going beyond the sole engineer working on a singular product on their desktop to hundreds or thousands of people sort of contributing to one single source of truth of a code repository.
Yep, exactly, man.
So when it comes to working with ML workloads and ML pipelines and sort of the entire life cycle of the model, is that different than traditional engineering workloads? Are the types of like products that they need to support that fundamentally different?
Yeah, for sure. I mean, let's take the regular software development workflow, right? I check out, I'm probably using Git. I check out a Git repository, I cut a branch, I make some changes, I push that up to some central repository, maybe GitHub, and I write some tests. And then when I put that up, people can look at the exact lines of code that changed. We can have some discussion around it, and the test will run, and I'll know if things are passing or not. With machine learning, you have code, so you're probably still going to be using GitHub, and you'll be making changes to the code. But it's not the code itself that you evaluate. You're actually going to evaluate this model that is, it's made up of a bunch of weights and biases or parameters that are learned through the course of training it. And you're going to then take that model and do an evaluation on it, test it on some data you know the answer to, and see how well it is or how well it's doing. And it's always going to get some wrong. It's never going to be 100% correct. So the big shift in mindset here is, as a software developer, I write logic, and if it's either right or it has a bug, that's it. There's one of two options here. With machine learning development, it's going to be like kind of right, or it's going to be right with some probability. So you need to start designing systems that take that into account. What do you do when the model predicts something at a low probability? Or how do you inform the user about the confidence of such a model? And then, as you're making these changes, you need to compare it against some baseline. Anytime you retrain these models, or your data set changes, or the code that interacts with that model changes, you're going to want to evaluate how good is this doing versus some existing baseline, which is probably the model you currently have deployed. And that tends to be a much more visual process. Like, it's not just, okay, that model's 96% accurate. This one is 97% accurate. Let's ship it. It's usually like, all right, now let's look into the examples and see which ones changed. Like, which ones did this model get right and now this new model is getting wrong? Are those actually more important or critical to the actual end use case? In that case, maybe 90% accuracy isn't better, and I need some new metric that takes into account these important edge cases. So it's a very different workflow that requires very different tools.
Mm-hmm. And then you mentioned the sort of evaluating like how good a model is. So how does using weights and biases help me evaluate, the different iterations or versions of my model and determine whether like one version of that is outperforming the prior version?
Yeah, so the weights and biases interface is very visual. It allows users to describe whatever metrics are important to their use case. And every single model is going to have some different set of metrics. But the simplest to think about is just accuracy. Let's say we're building a model that classifies documents as either spam or not spam. So you can measure a metric that says, all right, I got 98% of my classifications correct. By logging those metrics to weights and biases, you can then compare all of your experiments to see, all right, well, which model or which set of hyperparameters actually ended up giving us the highest accuracy. In addition, weights and biases has these rich graphical ways of logging data. So you can log essentially a data frame maybe of actual prediction results. So you hold out some test set of important documents that you want to definitely classify as either spam or not spam, and you know what the answers to those are. You can log those as tables, and then we allow you to kind of pivot and dive in and see individual examples and maybe compare two different experiments side by side to see how the model is changing.
Mm-hmm. And how do I diagnose like where a problem exists?
Yeah, I mean, by looking at the data generally, I mean that's the only way. It ends up, machine learning engineers often spend more time kind of analyzing the data that the model was trained on, or analyzing the evaluation results coming out of the model to understand its failure modes. Now, especially with deep learning, I say understand lightly. Like, you can understand that it's getting it wrong. It's going to be hard for you to figure out exactly why it's getting it wrong, like on the insides of the model. The best you can often do is say, okay, well, it keeps on getting this example wrong. Let's provide more examples of what I want it to do in the training set and see if we can't kind of spin the model more towards the direction that we need for our business. Mm-hmm. And I mean, the most important thing is just measuring what you want to evaluate. Like, it's not always clear, especially with these large language models, how to measure the quality of them. Nowadays, it's often conciseness or correctness, and these metrics are kind of hard to define mathematically, but really important to have, because you need kind of a stable way to compare things to be able to ship code that doesn't cause downtime or bugs or end user issues.
Mm-hmm. And then, is it similar approach? Essentially, it just comes down to kind of like really diving into the data and running experiments to determine whether something is a bug versus an anomaly when testing the output of a model.
Yeah, well, I mean, like, the weights and biases system keeps track of any of the source code that was used. So it might be, that's the other issue with machine learning models. It's hard to know if it was something wrong with the data or something wrong with your code or something else. Like, the machine learning model is happily going to output stuff unless it's really broken, in which case, like, the model itself is broken. But if there's some mistake in the way you loaded the data or evaluate the data, the model's still going to make predictions. They just might be really bad, which is why you need this like second level of checking, which is to evaluate it on data it's never seen before, to ensure that there isn't a bug in the code or in the data itself. And by using a tool like weights and biases, you can dive in and see the difference between the code of two runs to see, oh, well, could it be, or what did change? And then you also get to keep track of each version of data, so you could see like what records were added or removed that might be responsible for this regression.
Mm-hmm. And then what about reproducibility? I think that's a challenge in with a lot of ML experiments, especially with LLMs, because the input might not always equal the same output, even if I run the same input over and over again.
Yeah, and especially with like settings like temperature, you're like adding randomness into the output. Yeah. So it's literally never going to say the same thing again, which is why choosing that performance metric is important. It should be, it can't just be like an exact string match. It has to take into account correctness in whatever form that might be for your use case. In terms of reproducibility, as mentioned before, like weights and biases has always tried to make it as easy to be able to reproduce these experiments, because that's the only way you can go and debug or find what's wrong with something that changed. So we capture the code, we capture like exactly what arguments were passed to the script when you ran it, so you could like run that exact script again. It's still up to the developer to try to reduce any randomness in their code if they really want a similar run as last time. So PyTorch, for instance, lets you set a random seed so that the randomness is at least something that you can have happen the same each time. Mm-hmm. But with things like temperature, you're going to get some different answers. So the way to counter that is just to ensure your evaluation metrics are robust enough to handle that.
Right. Yeah. So it's not a matter of just like simply checking the output for, at least most likely not a matter of just checking whether the output is an exact match each time, unless you're essentially fixing the experiment to do that. It might be a little bit more complex in terms of the evaluation criteria.
Yeah, I mean, you can make the LLM into a classifier where you know what the classes are. So you can just literally check to see if the classes end up in the string. And if they don't, then it's wrong. But usually the more interesting tasks are much more nuanced.
Yeah, absolutely. And then the types of problems that you're seeing and you're helping people solve in the space are the challenges of the ML engineer that's working, maybe in the private industry or the enterprise, different than those from like the research community?
Yeah, for sure. I mean, in the research community, there's often more individuals that are able to do the research. So there's less need for broader collaboration. But if you look at the more recent kind of bigger papers, there is generally like big teams working on it. So there is some overlap in that sense. The big difference is like the class of data and the risk around that when in business. So in academia, you're using some academically licensed data that's open in some way and isn't all that sensitive. In industry, you're often working on sensitive data or data that is important for it's like companies' intellectual property. So suddenly all these additional controls need to be put in place to ensure that data isn't leaking and that it's being used in compliance with things like GDPR and other regulatory frameworks. So the kind of need for governance and reduction of risk in enterprise is a big change. And then the environment's just different. The ways in which you collaborate, the different stakeholders that need to get buy-in in academia versus industry is very different.
Mm-hmm. Yeah, you mentioned privacy, security, and like governance. I think that's definitely something that's very sort of front of mind right now in the generative AI world, where only a few months ago, Italy, temporarily they now removed the ban, but they banned ChatGPT for some period of time, and there's been companies that have locked down access because of fear of essentially leaking core IP or in the Italy situation was it compliant with GDPR or not, and of a number of different countries are now sort of fast forwarding to build regulations around AI. So that's something that I think is going to be like a growing concern for anybody that's investing in these technologies in the sort of private industry moving forward. The other thing that outside of that comes to mind with some of the differences as well could be around like failure rate. In a research experiment or something that's just a demo, having some level of failure might not be as big a deal, but when you essentially take that to scale with potentially serving millions of users, then something that is essentially an element of failure or an error rate or something like that could be pretty detrimental essentially to the product offering. So what are some of the things that like are strategies that you're seeing from companies to sort of like handle or combat that or potentially reduce the scale of a flaw within their model?
Yeah, I mean, well, number one is like evaluating. You need to really understand how your model fails. So not just at what overall rate, but in what ways. And then often in business, there are specific cases where it's really important not to fail. So even if overall accuracy is 99%, but the 1% of the time that it does fail is this case where it's like really not good for the business for it to fail. You need to find ways to work around it. I mean, what we saw oftentimes at my previous company was people would put machine learning models into place that weren't that accurate. But the nice thing about machine learning models is that they output their probabilities. They tell you how confident they are. So they're going to output an answer, but they'll also say like, I'm only like 20% sure. So to mitigate these failure modes, often, in the cases where that false positive or the false negative is really critical, and you have a low confidence, then you change the user experience. Either that gets routed to an actual human being somewhere to make a choice, or there's special kind of UI or ways in which the user is informed, like, hey, this is a guess. It's not, it might be wrong. You need to like really double check here. Mm-hmm. So it's kind of like similar problems in in just the regular chat interface, like ideally the UI could say, we might be hallucinating here, or certainly they've done a bunch for safety already to ensure that the models aren't outputting content that would be like really offensive or dangerous.
Yeah, absolutely. And then I think context is also a big factor of like, what is the problem that you're applying the ML to? Like if I'm using something like, I don't know, some sort of, personal device that is going to automatically recognize the exercise that I'm doing. And once in a while, when I do a sit up, it thinks it's a push up or something like that. It's probably not that detrimental. Like the consequence of that error is not that bad. But if I'm using some sort of machine learning to, read a scan of my eye to detect whether I have some sort of, cancer or some other health issue, the consequence of a false positive in that situation or false negative is much more detrimental to the individual involved.
Yeah, this is why we don't have mass market self-driving cars, even though Elon told us we'd have them 4 years ago.
Yeah, exactly. The consequences of mistake is very, very high when it comes to things like self-driving cars. So, we touched a little bit on generative AI and LLM. Do you think the tooling involved with LLM work is potentially different than the tooling needed for the sort of more traditional ML?
Yeah, for sure. When we started this company, we were really focusing on the researcher, the people that had studied machine learning and were interested in modern machine learning approaches. So the product is like really designed for that user in mind. Very math heavy, very advanced in that regard. Now with LLMs and these APIs that any software developer can use, the product really needs to start looking a little different for that type of user. The core problems are the same. Like we need to evaluate these models. We need to keep track of maybe what prompts or chains we're using as we build out our applications. But the end user isn't as excited about being able to write LaTeX in a report to describe some novel like loss function. They want clean APIs and a lightweight SDK that helps them get their work done. So, our team has been working a lot to focus on building out more functionality that is targeted at this much more broader ML generalist that we think is only going to continue to grow.
Mm-hmm. Yeah. So, what are some of the investments that you're making there? Essentially, there's like the democratization that's going on around ML, where, as you mentioned, any software engineer can hit essentially an API endpoint. If you ever use REST APIs, you can essentially take advantage of these, massive models now to do all kinds of like amazing things to enhance products or create new types of products.
Yeah, well, one of the big ones that we just released is our production monitoring for LLM APIs, essentially. We actually created a proxy which complies with the OpenAI spec. So you can use it in front of like OpenAI's APIs or any of the third-party open source APIs that are now serving up all of these amazing models that are open to the world, generally using that same OpenAI schema. I always mix Open AI and Open API. There's an Open API spec for the OpenAI API. Mm-hmm. By using a proxy, what this means is that engineers can just change a couple environment variables. Like the OpenAI SDK will respect a couple environment variables that say, now send all the traffic through this thing first and then go to OpenAI. What this then gives companies is the ability to have visibility into how their entire team are leveraging these APIs. Is PII leaking? Do we have a hallucination problem? How much are we spending? Which teams are the biggest users of this? So like really important questions that I think all companies want to be asking that we unlocked with our production monitoring suite that was released just a couple of weeks ago. The other thing is we have a really cool integration around traces. So just like in like Datadog or other kind of APM application performance monitoring tooling, you can see these detailed traces of where time is being spent and what services are being called. We allow users to keep traces of their like LangChains. Whether you're using, say, the official LangChain SDK or building out custom chain of thought or agent-based programs, you can capture kind of all of those different spans and then quickly debug and see where time is being spent or maybe where errors are occurring in those complex chains, which has proven to be a really popular feature as well.
Mm-hmm. Do you think that as this area of LLMs develops, there'll be some consolidation that happens? Like I feel like if you look back to the beginnings of the cloud era, there was people who resisted the use of the public cloud, and they're like, we're going to build our own cloud. And then I think eventually people in the last few years, like even banks are now starting to move on to like AWS and these different services, recognizing the value that's there. And I feel like at the current time, there's a lot of people who are, maybe resistant to some of the open source models out there, and they're trying to build essentially their own foundation models. But do you think the future of this is that we'll end up with a handful of like clear winners, and essentially most things in terms of customization will come down to fine tuning or augmentation or maybe prompt engineering?
Yeah, I mean it's hard to predict these things. I would say personally, I'm really excited about the open source ecosystem and the models that are being released there. Just going to like the Hugging Face Hub and seeing what's popular or trending this week is now kind of a part of my routine. And especially when you can run these models like on the edge or on more constrained devices, it unlocks a whole bunch of very interesting use cases that just aren't there when you're calling out to some third-party API or when you need to run like a really big model using multiple GPUs that costs a lot and is tricky. I think there's definitely going to be a place for the players like OpenAI for these really big models that are like way more advanced, but they can be used to actually evaluate these smaller models or to generate training data for the smaller models. So they're definitely a part of the chain, but I think we're going to see more and more growth on the open source side. I think, companies building their own foundation model from scratch, we work with a lot of those companies. But I don't get the sense that is going to grow substantially. I think building on top of well-licensed, well-trained, more open models feels like where things are going, but I could very well be wrong.
Yeah, I mean, I think that if anything's consistent with human history, when technology innovation is involved, whatever our predictions are today, they're probably massively wrong to the future. Actually, going back to that, so you, like as I mentioned earlier, you've been in the space for a long time, and you mentioned at the top of this interview that in some ways, like sort of what we're seeing from systems like ChatGPT and what we're seeing in the LLM space is like we almost need like a new word for it because it's so impressive. It feels like something new and something transformative. Are we, based on where you started your journey in the space, do you feel like we're ahead of what you would have imagined where we'd be today from a, AI ML sense, or is it surprising to you that of actually, where we are right now relative to where you started?
Yeah, I mean, I think I'm impressed. Like I don't know if I tend to not have big expectations because that's like a recipe to be disappointed. But I think what I've seen, especially in the progress with these large language models, right? So Weights and Biases has been working with OpenAI for many years. And we were early users of GPT-2, and then we played with GPT-3. And we're pretty excited about these things, but I don't think even then we understood like how big of a deal they were. It wasn't until ChatGPT was released about a year ago that the world understood how big of a deal these things are. But knowing that ChatGPT 2 was like, oh, it's interesting. ChatGPT 3 was like a little more interesting, cool. And then there's this inflection point, I think largely due to just the beautiful interface that ChatGPT has and how you can like easily interact with it. There's no indication that progress is going to slow. So it seems like as Moore's law continues to unfold and we double the number of transistors in our chips, the models are just going to get better. Now, it's been a very common thing historically, especially in AI, for us to say things like this, and then we hit some like unforeseen roadblock and things kind of like peter out. But everything today is showing, continued improvement. So I think if we're impressed what we have today in a couple of years, there's there's a high likelihood that we'll continue to be impressed.
Hmm. Yeah, you mentioned the beautiful UI of ChatGPT, and I always say like that's really, at least in my experience, that's like what brought AI to like my parents, who are retired in the 70s and never worked in technology. Like the fact that they even know what generative AI is and it's a thing that people are talking about is it feels like a step function for me because it's really in the zeitgeist of essentially everybody at this point if it's hit the retirement community of rural Canada. But the other thing you mentioned there was that there's been these like times throughout history in the ML space where we maybe thought we were going to see an explosion and there's like a roadblock that we hit. What is an example of a roadblock that was hit in the past that had to be overcome?
Well, I mean, the original idea for deep learning or neural networks um, was had in in the 1950s
Yeah.
by Frank Rosenblatt, and there's like an article in the New York Times with Frank saying like, yes, this is the beginning. In the next few years, we're going to have like these automated machines that can do these various tasks, and that certainly did not happen. And in fact, like when my co-founder Lucas was at Stanford learning machine learning, they were considering taking deep learning out of the curriculum because it didn't seem as promising as the other algorithmic methods. So it's like really easy to be wrong and not know what's actually gonna work here.
Yeah, neural network research was essentially defunded in a lot of countries for years. Like it was kind of had spikes in the like late 70s, early 80s. And then for a long time, people just stopped doing it, probably because of basically it was like computation limitations as well as other things. But so then they focused on more pure statistical methods and some other a variety of different tools to build models, build classifiers, and then Canadian researchers kept some of that going through through the 90s and the early 2000s, leading to today. So this is your second startup, and you've been at this for a little over half a decade now. What is like one of the biggest surprises from as a founder or two-time founder that you learned along the way, or something that maybe people ended up using the weights and biases in a way that was completely unexpected from what you thought they might have been your vision for it was?
Well, we actually we have this feature that allows people to create kind of custom visualizations because it's very visualization heavy, and it's built on top of this technology called Vega, which ultimately kind of compiles down to D3, which is this visualization grammar. And one of our engineers at Weights and Biases actually took this Vega spec and made like an actual like RPG game just writing Vega, which was kind of insane. So you can navigate with your keyboard and jump around using this kind of obscure language that few people knew. That was like really impressive to me. I think some of the coolest use cases in the platform itself, there have been some gaming companies that are using generative AI to do some really cool stuff, and kind of seeing and talking to those teams and how they want to use the product. The thing I like the most about this company is that our customers are so diverse. We have people in agriculture, in bio, in medicine, in automotive, and e-commerce, and just every industry. There are use cases here, and our tools can hopefully help them achieve their goals. So it's just been awesome to work with such a diverse set of companies.
Yeah, it's not like it's a vertical play. You're basically serving the engineering needs of ML engineers, which is an ever expanding, an ever expanding market and actually exploding market at this point.
Yeah, the timing on this company was definitely better than the timing on the last company. We thought machine learning was really cool, but the rest of the world didn't 15 years ago. And this time around, it seems like the timing couldn't have been better.
Awesome. Well, as we start to wrap up, is there anything else that you'd like to share? Any updates that people should go check out?
Yeah, I mean, I think the big one is for any organizations that kind of want to monitor their LLM usage. Check out our new LLM monitoring functionality, and for teams doing kind of chain of thought or reasoning or retrieval augmented generation with these models, definitely check out our LangChain integration and use our cool new kind of tracing dashboards.
Awesome. Well, Chris, thanks so much for being here. I really enjoyed this, and best of luck with everything. I'm sure. Like I agree. I think the timing is right. So I think that things are going to be only exploding from here. Cheers.
Appreciate it, Sean. Thanks for having me.